Hello Internet. Today we are going to be putting a Minecraft server inside of Docker. You might be asking why we do that, and there's a few reasons. One, Docker is a really handy way to make an instance of something and move it to a bunch of different places really easily. And it's also a really nice way to run multiple things on the same device without them interfering with one another. And at least in my case, I have like a shared server. And so Docker kind of makes that easier because then I don't have to worry about it like somebody going crazy in Minecraft and using all of the resources for every other process on that server. It just kind of makes a sort of a unified abstraction over what you're hosting. If you're not familiar with what Docker is, this is sort of hopefully going to introduce it just a little bit. I'm not going to go super in depth, but I'm going to kind of introduce what a container is because that's kind of core to this whole point. So a container is a container. And so the general idea is it sort of encapsulates a process, a single process usually, and prevents it from interacting with the environment outside of it, and prevents that environment from interacting with the container. So like, here are some router bits, just as like a really quick example. And as long as the case is on them, they're not going to be really damaged, and they're not going to like scratch my walls or my floor or whatever. But if we open it or something, suddenly bad things happen, and that would sort of be like an uncontained thing, just sort of like running bare code, and we don't really want that. And so containers are sort of that layer that makes it possible to say, here is the fixed environment that I want to run in, and you can put that fixed environment anywhere. You can put it on a Windows device, you can put it on a Linux device, you can put it on some server somewhere, you can throw it in the cloud, and as long as that image doesn't change, it should work everywhere that supports those kind of images. And that's sort of a really handy feature because it means that you can build your server and then move it somewhere else and run it there, and it should work the same way. There can be some caveats there, and it may not always work the same way. But generally that's the idea, and it makes it a really handy way to, say, debug it locally here, and then put it on a server or host it in the cloud, and not worry too much about it. And that's just kind of convenient. It also is really, really handy for setting up things quickly. If you've ever hosted like a Minecraft server, it stores things in like your app data. And so if you were trying to run like multiple of those, they would conflict. Because they're in that container in Docker, that isn't going to happen because everything is separate. So the entire file system is separate. And that means that you're not going to get conflicts like that. Same thing with like environment variables and things like that. It prevents those kind of like finicky things of trying to coexist in the same space. It kind of removes that problem from what you're trying to solve, and so that makes it sort of handy. But we'll kind of get into this. This is going to be sort of a quick example, and it's sort of something that I already have done. I tried to record it when I set it up, but I actually already have like a server running. This is my configuration. And so the general idea is it just sort of makes it easier to do things. So I'm going to kind of walk through like the basics of how to get it set up, and then you can kind of tweak it to your own specifications or just run it locally or whatever. And hopefully that's enough. If there's other questions, leave them in the comments, and then I can either follow this up with another video or answer them there or whatever makes sense. So final thing, I turned on Visual Studio Code's assistant mode, or like Visual Assistant, it's the screen sharing mode, developer screencast mode. And so what that does is shows you when I press keys, and also like click the mouse and do like hotkeys. And so theoretically, it should make it easier. A few people have commented over and over on different videos that the text size is either too small or whatever. And so hopefully that's a good solution to that. It's a fairly new thing, so we'll see how it works. I don't know. But anyway, we're gonna get going here. to get started, you need Docker. If we're going to be running things in Docker, you need Docker. There's a bunch of different ways to get this. If you're on Linux, it's going to be like apt-get install Docker or whatever your package thing is. If you're on a Mac or Windows machine, Docker has an application called Docker Hub, or not Docker Hub, called Docker for Windows or Docker for Mac. And that's going to add something like on Windows, it's going to add something to your taskbar and say, give you all of these options to kind of control your thing. It has some other fun stuff in there like Kubernetes. It really doesn't matter. You can pretty much just install it and you'll get Docker. And so you can run this and it will say, I have no idea what you mean. Here are all the things I can do. So the first thing we want is to pull the image. So the name of the image usually has two parts. I'll just pull this up because this is the image we're using. Docker is pretty handy because this is on Docker Hub, by the way. Their image repository, it kind of a set of predefined images for you. It's sort of just an easier way to do things. The way Docker works, should probably cover this, but the way this whole thing operates is it's sort of a stacked set of things. So at the very top, you're going to have your operating system, whether that's Linux or Windows. You kind of choose that. Whoever makes the image chooses that, and then you're going to have some extra files, maybe in this case Minecraft, or some other configurations or things like that. There's a whole boatload of different options, but the general idea is those get layered on top, and then you come in and put a few extra layers after that to kind of finish it off and say, here's some extra configuration, do this, go. And so that's the general idea here. And so the first thing we need to do is get that template image. And so Docker pull and then the name of the image. So usually if you're working with like Docker Hub, for example, it's going to be the name of the user followed by the name of the image. That's just generally how things are labeled. And so we should just be able to go /Minecraft server. Pretty sure that's correct. We'll see. And so what it's going to do is download everything. These hashes, or all these hashes here, are the layers of your Docker image. So you've kind of got all of these. They kind of matter in a way, but you don't really need to care about them at this point. So there's some optimizations you can do. But there you go. We've pulled this new image. I already had one, which is why some of these already existed. But it had been updated since I had pulled it. So we have some new updates that were layered on top of that existing version. And so now we have this itcg Minecraft server latest. And so what we can do with this is actually run it. So let's open this. I'm going to throw that over there, and I'll kind of walk through what some of the things it's saying. I'll put the link to this in the description just so you can kind of browse it yourself. This image is the one that I found works the best. I think there's a few for Minecraft. There's some for Factorio and a few others. Usually it's used for like backend and web development stuff. But anyway, so the command that we really care about is Docker run. Docker run is going to run an image. And so what we can do is just run this image. This won't work, but we can do it anyway. And so I'm adding this latest, and it's sort of specifying a version. And so this image can have multiple versions. Like I had a previous one, and now I have the latest version. The latest version is sort of a default thing in Docker, and it represents the most recent one. You can also give it like a number, like 1.3. That number has to actually exist, and I don't actually know which ones exist. So we're just going to use latest because test. But for the most part, you probably don't want to use latest. And the reason for that is if it updates for whatever reason, and you try to run it again, generally you want running this, like a Docker run command, to do the same thing every time you run it. if you're using latest, that isn't actually what's going to happen, because if somebody updates the image, like I just did here, what was working previously is no longer going to work necessarily because we have a different image. So which means there's new stuff there. It's like getting an update for a game. New things are broken, new things have changed, whatever. And so latest can be a little bit finicky. It's all right in this scenario, most likely, but we'll see. So if we run this, it's going to break. Because what we have to do is accept the end user license agreement. Minecraft has an end user license agreement that says, I agree to all this fun stuff. You should read that. And so what we need is to specify an environment variable. And we can do that by just typing -e, which says the next thing is an environment variable. And then that's just end user license agreement equals true. And we can do this and run it. And you can see it's downloading Minecraft, doing all these things. And if you've run a Minecraft server, this should look familiar because it just started a Minecraft server. The problem with this is you can actually see, like, it is running. We have the port open, things like that. The problem is it's a container, so everything is inside of that box. We need to open that box because if I go into Minecraft and go to multiplayer, ignore these two. Those two are something else. But if I were to say add a server at localhost, it's not going to find it. It doesn't exist. And that's because, well, it doesn't exist. Also, it's creating the world, so that might be a poor example. But ignoring that, we're not going to be able to connect to it anyway. And the reason for that is everything is exposed on ports, but it's an internal network, which means only other Docker images are going to be able to see what's happening in this server right now. And we want to get in. And so the way to do that is to actually expose the port. And so we have to tell our Docker daemon to actually redirect traffic from whatever port to whatever port, and sort of create a mapping from our PC into the Docker environment. And so we should probably not have this running anymore. There's two things we could do. So if I do Docker PS, we still have this image running. By default, they get given this name, Sad McNulty. Great name. And that's pretty much it. You can see there's two ports that are being used, but they're not going anywhere. And the command it used was /start. This looks better on a smaller screen because it's a single line. But you can it gives you a little bit of information. It can tell you the image you're running and the name and the container ID. The container ID and the name are independent, like you can use one or the other when you're referring to it. I prefer the name. And so what we can do is do Docker stop sad McNulty, and that will stop it. And so if we do Docker PS, which is going to list the running processes, we won't see any. The problem with this is if I try to start it, sad McNulty, it will start, but we still don't have that port exposed. This image is kind of broken. And so we just don't want it here anymore. So let's stop that and we'll remove it, I guess. That didn't do what I wanted. Maybe. Backspace. There we go. Docker rm sad McNulty. And so that completely removes it from the machine. So which means if I try to start it again, it's not going to know it's there. If you want to just normal operating procedure, like bring something down, stop is what you want. RM is actually going to kill the thing, which means everything that was in that container is gone. We generated a world previously. That world doesn't exist anymore. We just blew it all away. that container was burnt in a fire and destroyed and smashed with a hammer. And so that's sort of one of the gotchas of a container environment, is it's really easy to lose your data if you're not careful. We'll get into how to save that in a bit, but that's something that you should be aware of, because if you just naively start bringing up containers, especially if it's like important business data, maybe not so much for a Minecraft thing, unless you spend a lot of time in your Minecraft server. But like if you're storing like customer data in Docker, it's a good idea to have it stored like outside, or at least have some sort of backup, because it can go away, and it can go away real easy. So that's that. Anyway, what we want is to expose a port. So let's go all the way back up to this run command. We're accepting the end user license agreement. So let's also add a port. So we're going to do -p, and Docker or Minecraft server is hosted on port 25565. And so we want to map our local host's port 25565 to the Docker host's 25565. And so that is going to create a bridge between those two ports from my local machine into the Docker environment. And so that way, when we connect on that port, we'll actually get into the Docker environment. If we don't do that, we can't see it. But if I run this again, it might take a bit because we're actually going to have to regenerate our server. But this should actually expose it so we can connect. At least that's the general idea. And that's sort of like the basics of doing it. This image has a lot of other configuration things. I'm not going to go into those because it's just it depends on your preference. Like if you want to run Bucket, for example, or Forge, those are options, and it will pull different things in, and you just need to tell it to. And so if me showing you that, I guess, is interesting, but not a great use. So if that's something you want, let me know. But we have our server created there. Just spawn the entire area. It took 14 seconds. And so the trick should be, I should be able to refresh this, and we'll see we have a vanilla Minecraft server powered by Docker now. And so I should be able to connect to this, and down here, you can see RuneWake 2 join the game. And so now I am in our Minecraft server. That's it. We now have a Minecraft server. The problem is I can really, really easily destroy this because we don't have any persistence, like I was kind of mentioning before. And so the next step, I guess, is going to be creating that persistence. And so one thing that Docker lets you do is called creating a volume. What that does is actually maps information in the Docker host onto the host machine's file system. So if you want to put some information somewhere actually on your machine, that's how you would do it. And so let's kill this one last time. The name is auto-generated. So this one is Youthful Goldberg. That's a good name. So let's remove that. We're going to get a different image. I can't kill it because it's still running. There we go. All right. So that world is now gone. When we recreate one, we should see a different seed. So the world should look different. That one had like birch trees and things. This one, the next one shouldn't. And that's just part of the way this works. So volumes. To create a volume, let's look at that, because that's not how you do that. Nope. Help. There we go. Volume. Cool. So I already actually have a volume that I use in my server. It looks like this, which is mapping this actual physical space into the /data drive inside the image. /data in Minecraft is like the everything. And so that's going to store your world data, your player information, mods you may have, things like that. One of the cool things with doing it this way is it means you can just kind of drop your mods into this data folder and it works. And so that's sort of a handy thing. So that's the format we want to copy. This is the source directory right there. And this is the target directory. So this is where the data is going to be stored inside of Docker. So we need to modify this run command to have a -v something. Part of the problem with this is I don't actually have a dash anything. So I think, is this a good idea? I don't know if this works. Let's find out. So let's do temp data to /data. So this should create something at the local or the relative directory. So we should, if this works, see a new directory pop up here with all of our files start getting populated there. Theoretically. I haven't actually ever tried this, so it might not work. I've always used absolute paths in the past, so yeah, worth a try. So if this works, we should just see it replicated there. Let's find out. It seems to be fine. We may need to refresh. I don't really know what's going on. Well, that's not helpful. That's not helpful at all. Deploy. It doesn't look like it created any data folder. There's only 3 things there. Did I do that wrong? I might have done that wrong. I don't think I did that wrong, but I might have done that wrong. All right, this is silly. Let's kill that. Docker PS. Sorry, this is getting a little bit full. There we go. I don't know how to pronounce this, but we'll stop that. And docker rm that. So that's gone now. Cool. That terminal is just dead. Dead. Great. Okay. Well, good to know. Does our history work? Yes. Cool. So let's get rid of this dot and do e:/development docker compose Minecraft /temp data. I'm also going to do one other thing and actually create this folder first, because I don't know if that's required, but I feel like it might make sense. So let's make that directory. Cool. We've got a temp data directory. I don't know if that'll make a difference, but we're going to find out. And then we'll run this again. And there we go. That's sort of what I was expecting to happen. And so you can see all of this stuff is starting to pop into this folder. We've actually got the Minecraft server, the server properties, all of this fun stuff. And this is actually going to persist. So if I actually remove this Docker image, this stuff will stay behind, which is handy because it means you can just zip this up and throw it somewhere safe, wherever that might be, and it shouldn't go away. And you should be able to sort of restore things if you want to. So that's sort of one way to maintain your server. Last thing I kind of want to show is after this finishes generating all this stuff, we should be able to load into the server and see something new. And that should be pretty much the end of it. Hopefully, hopefully everything kind of goes as expected. But I don't know. This is sort of how I run my Minecraft server at home. So it sort of just makes it easy. Yeah, there we go. Now there's a village. Well, that's convenient. Cool. Totally different world. And you can see we joined the game, we left the game. This is not the most efficient way to run this kind of stuff. When you're running things like this, it's kind of handy to have it immediately go to the logs. We can actually get that's dogs. Docker PS. We can get to the logs in another way. We can go logs hopeful hertz. That's a fun name. And it will print out more information. It will print out the logs, and you can add a -f, and it will just follow them like we were doing previously. This is handy if you run commands with the -d command. So let's go here and stop this. That's not going to work because if I start this, it doesn't actually attach. But if you do like -run d, what's the name of it? Minecraft server? If I do this, you're going to see something different. This is the run command again, but we're running it in the daemon mode, which means it's not attached to our shell. So if we do this, we just get a long fun hash out, which is actually the full ID of that Docker image. These like little short things, Docker PS, these little short ones are just part of this. The problem is you'll note this doesn't exist here. We didn't actually create that, except we did. Because I didn't sign the end user license agreement, I didn't have any of the things specified, it died immediately. And so it will appear like it just failed. If you want to see what actually happened, you'd have to go logs and enter the name of the thing, which is really long. And there you go. We get no changes. Please accept the end user license agreement, blah, blah, blah. You should also be able to do run -d and give it a name. So we call this Minecraft, like that. And if I go Docker PS, we don't see it again. But if I do Docker logs Minecraft, or not, hold on. Did I screw that up? Oh, I did. All right, well, we're making a mess. Instead of that, we do name Minecraft. Ta-da. It's still not in Docker PS, but we can do logs Minecraft now. And it has a fixed name, which makes it a little bit handier if you're actually like writing scripts for this, because you don't have to remember the hash, because the hash is gross. And that's that. So hopefully this gets you started and kind of gives you a way to tinker with Docker, because it's super fun and really useful, and not just for making game servers. If you're ever trying to like host a website or anything like that, this is a really easy way to make something that you can put almost anywhere. You can pretty much throw this on any cloud provider, whether it's Amazon or Google or Azure or whatever, and it will just work. And that's really, really handy, because the same thing that I'm running here, I can put up in the cloud or on my server or wherever, and it just does its thing, and that's handy. So I think I've hit that point like 8 times, probably more, but it's probably the most important point of this entire thing. Is the point of Docker is to create reusable and sort of disposable images of software, sort of like an executable or an installer, but for servers, which is super nice. So yeah, hopefully it's just a nice way for you guys to go and tinker with it. But if you guys are figuring things out and finding new things, let me know in the comments. I'd love to hear what you're making, what you're learning, any questions you have, things like that. If this wasn't helpful and there's other things that you want me to cover, or things you want me to change, or any of the new stuff I was trying, like this presentation assistant, if that's not working for you, let me know, and we can change that. But that's it for this video. So until next time, see you, Internet.